Hi everybody, Dr. P here, and in this lecture video we're going to take a look at the Stork Enamine reaction. Now, why are we looking at the Stork Enamine reaction, and well, what is it? So the Stork Enamine reaction is based on the fact that enamines are better nucleophiles than enols. Excuse me, let me say that again. Enamines are better nucleophiles than enols. And if we take a look back at our Lecture 3 notes, we see that one of the Michael donors that we talked about was the enamine. Notice that enols are not here. And so we can use an enamine in a Michael type reaction. And we're going to make use of the fact that an enamine is in equilibrium with its ketone, the ketone that it came from. All right, so let's take a look at this. So let's take a look first at how we might try to do a Michael reaction. Okay, so let's say we had the following target. And we're going to use a Michael reaction. Now you may be tempted to say, all right, let's take, since that's going to be my new bond there, let's take that, and then let's take 1, 2, 3, 4, take that. So we'll mix these and NaOH. And we should get this product via a Michael reaction. And I've shown you a mechanism for that. The only problem is this is actually not very favorable. We also have competing reactions. Why is it not very favorable? Well, pKa here is 20 approximately, and we can have competing reactions. We can have all kinds of aldols. We could have crossed aldols. You could actually have this guy could form the aldol. So not great. So that's okay. We're clever. We can do this. So what if we start with this guy and first treat with LDA, and then we'll add in our hold on here. Boom, boom, boom. We'll add in that guy, and then we'll have to add some water to quench that. And that should give us now the product there. Okay? Sorry, this thing should be over here, so let's just make that guy go around. Anyway, you get the idea. The problem with this is LDA is nasty. So there are better ways to do this. And one of them is the Stork Enamine reaction. So what the Stork Enamine reaction looks like is we will go ahead and we'll take our aldehyde or ketone that we want to use as a nucleophile, and we'll convert it into, and typically we could use like some cyclic H there, and H+, so use a cyclic secondary amine, And that will give us now that guy. And now we can go ahead and add this to our alpha beta conjugated ketone there. And then we'll go ahead and we'll use H3O plus to hydrolyze that. And we will actually end up with our ketone. And this is the Stork Enamine reaction, sometimes called the Stork Enamine synthesis. So let's just take a look at the mechanism here. So really what we're doing is we're using some of the stuff that we saw back in chapter 19, and then we're bringing it in here. And there is a question with this sort of thing on the practice quiz, and there may be a question, sorry, the practice exam, and there may be a question on the actual exam. So let's look at the mechanism, just so we can see what's going on here. So there's my Stork enamine reaction. So we make the enamine, do the Michael, hydrolyze back to the diketone. So let's take a look at what's going on here. Okay. Let's take a look at our mechanism of our Stork enamine reaction. So we'll go ahead and we will start with our, let's get our amine, and we'll get nucleophilic attack. Again, I know that we've got, and one thing I forgot to mention here is this should be dilute H+, because we don't want a lot of acid, because that'll just protonate our amine and it won't be nucleophilic. So we need dilute acid because that is important later on. So we'll go ahead and we'll get nucleophilic attack here to give us a tetrahedral intermediate. And again, this is the one case when your nitrogen is your nucleophile and you're adding to a carbonyl. This is the one case where we're going to have a we're going to have a negative charge present. So now we can get a proton transfer, and once again it's fine to do an intramolecular proton transfer. OH, now we've got our alcohol, nitrogen, boom, 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 boom. We need to do another proton transfer here, because we have to make this guy into a good leaving group, have to make the OH into a good leaving group. You know, I'm not going to ask you to do this mechanism on the, forgot a lone pair there, sorry, I'm not going to ask you to do this mechanism on the exam, I don't think. But if you can do, by this mechanism, I mean the full mechanism for the Stork enamine reaction. I may ask you to do an enamine formation. And so now we have that lone pair goes there. And that gives us now double bond N. Boom, 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 boom. Positive charge. And now we'll go ahead and one of our hydrogens here, we can remove that with our nitrogen on our amine. So we'll go ahead and deprotonate there. Those electrons will go there, and those will go up there. And that gives us now our enamine. Now we'll go ahead and take our enamine and I'm going to go ahead and put in these hydrogens here. We'll go ahead and get our let's see, we'll get our, make sure that's a double bond, get our alpha beta unsaturated species here. And now we can go ahead and get that adding there. We'll get that adding there. And then we will go ahead and, let's see here. I'm trying to think of the best way to do this. I don't want to form the enolate yet. So, well, we can go ahead and do it. So, it'll be something like this. Okay, so I've got 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. That guy is there, minus. So I've got that guy. Now double bond there. H, H, H. Here I've got nitrogen and positive charge. Now when I add my acid, my H3O plus, again this is the second step here, I'll go ahead and do a couple of things. The first thing is I will I'll protonate to get my ketone. And now, since I've got water present from my H3O plus, that can add in, and I will get boom, 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 N, lone pair, O, H, H, lone pair, positive charge. I can get an intramolecular proton transfer here. Doesn't have to be. It could be solvent mediated, which is actually probably what it does. But you know the drill here. I'll let you take that shortcut. And that gives me now that guy N 1, 2 H positive charge. O, H, lone pair, lone pair. That'll kick down there, and it'll kick off there. And that'll give us now and now I can have, again, it's probably going to be my amine here because that's fairly basic. That'll come along, deprotonate, and I will get now my final my final 1,5-diketone. So the whole thing involves making the enamine, having that do the Michael reaction, and then continuing on with the hydrolysis of the product back to the ketone. All right. So I just wanted to show you this. I'm not going to hold you guys responsible for this mechanism, at least not at this time, but I did want to show it to you, and maybe you'll use it. Maybe you will use the Stork Enamine synthesis to make a 1,5-diketone. All right, well, I hope this gives you a little more, another tool in your arsenal as far as synthesis goes. And until next time, stay safe out there. Bye now.